Right. So hello everyone. Happy New Year to everyone, first of all, and welcome to our first episode or first webinar for this year, 2025. And this webinar is very special because here we have now is a fellow analog astronaut. He's a para astronaut, so he will be discussing space for all, a wheelchair user in an analog space habitat. If you're new to this webinar, so we've been doing this for about 2 years now. So our group is the International Astronomical Union Inclusive Outreach, and we've done a lot of webinar with regards to sharing astronomy and astronomy education in an inclusive manner. So the tools and the practices that we do to do inclusive astronomy outreach. And by the way, my name is Kristine Atienza, and I handle this webinar since the very beginning. And welcome again to our group, our webinar series. But I before we start, before I give the floor to Thomas, let's have some reminders. So first, the session will be recorded, or recording is now recording. Participants other than the speaker and the moderator are muted while the presentation is ongoing, and questions may be asked throughout the presentation by typing it in the Q&A box, or you may post your questions in the chat box, and the moderator will notify the speaker to address your questions. And most important is to enjoy the webinar. And again, come to this episode. So for today, again, we have a very special guest. So I think this is the first time that we're tackling about space because usually we do this webinar mostly for astronomy, for tactile resources, um, or sa- uh, uh, of getting sound bits from astronomical data, but now we will be discussing more of space exploration. So Thomas Ducai is a molecular biology master student at the University of Vienna with a strong interdisciplinary background in molecular biology, analytical chemistry, and biomedicine. He has conducted research at prestigious institutions, including ISTA and the Medical University of Vienna, focusing on cellular mechanism and genomic analysis. As a biolab officer during M2.24 analog space mission, he became the first wheelchair using participant in this field, further demonstrating his adaptability and commitment to accessible science. He's also an active member of the NASA Gene Labs Analysis Working Groups and the Community of Human Analog Space Missions, CASA, combining his interests in space sciences, biomedicine, and molecular biology. So, without further ado, let's all welcome our resource speaker for today, Tomas Ducai. Am I pronouncing your name right?
Yeah, thank you very much, Christine. It's a real pleasure and honor for being invited and telling you something about my experience as an analog astronaut and in general about inclusive initiatives in the world of space exploration. So before we begin, yeah, let's imagine you are on a space mission and either on the moon or even on Mars, and something happens. Either it is you or someone of your crewmates regarding the health, and someone's getting a serious health issue which cannot be resolved within hours or minutes. Um, this scenario sounds challenging, and in fact, it is, and therefore, it is really, really crucial that the future real astronauts are prepared for such a scenario where something like that happen, where taking in mind we don't have the chance of getting back to Earth. So for these cases, in order to gather research from these settings of having a specially able person as a crew member, there are these analog space missions, simulated space missions that simulate such scenarios. And now let me share my screen in order to dive directly into the presentation. Can you see it? I hope so. Yes. Perfect. So um, just quickly something about me, as Kristine already introduced myself. I've graduated at a Viennese high school, including within the subjects biology and astronomy. I have completed a Bachelor of Science degree in biology with a focus on microbiology and genetics, and currently I'm pursuing a Master of Science degree in molecular biology, focusing mainly on developmental and stem cell biology. Um, in the scientific, let's say, aspects, I'm also a member of SGAC, the Space Generation Advisory Council, which is a huge, huge network for students and young professionals in the space field. And especially, I'm active in the working groups of inclusion and diversity, the space sector, space biomedicine, and the diversity, equality, and inclusion rights division. As already was mentioned, I'm very honored also being a member of NASA Gene Lab, especially there in the working groups of multiomics and microbes, where we analyze biomedical data uh, having received from real space missions. Also, what I will be also talking about during my talk will be that I'm board member of a really unique, great organization called CHASM, the Community of Human Analog Space Missions, where I'm leading also the subgroup called ParaCHASM, where we are focusing on the research of specially abled people in the analog space, simulated space sector. I'm also a member of the Austrian Space Forum, and having been speaker at numerous conferences, as well as being nominated for an UN campaign 2 years ago, were under the title "Celebrating Youth Lead as Agents of Change for the Global Goals." So, what are analog and simulated space missions? Yeah, it is, as the name says, a simulation of aspects of real space missions on Moon or Mars, and this can happen um, numerous environments, as the focus of such an simulated space mission can be either or mainly on the simulation of the conditions of space, or like the moon or Mars, planet or moon, that is out there. So in this case, this analog space mission oftentimes is located within an analog space habitat in an extreme condition. This could be a desert. This could be also, but on ice. Like the Antarctic missions, sometimes it could be also on volcanoes or within volcanoes. Like there's some mission on Iceland and also on Hawaii, the high seas habitat, for example. And so this is one aspect where the analog astronauts are trying to simulate the space conditions as best as possible. Um, or there is an aspect also to simulate the interpersonal relationship. So focusing more on the human factors, then the habitat is or does not necessarily have to be in harsh extreme conditions, but in this case uh, there is the focus on the simulation of the interpersonal social interactions, let's say. So, but as having introduced this, let's say, extremer or harsh conditions on Earth, for sure. We can have it also underwater, but also zero-G flights, parabolic flights, which are also performed by a couple of initiatives, are also or could be also seen as simulated space missions, where this is the only aspect where we can really simulate, at least for a couple of minutes, the weightlessness and zero G conditions. And as you can imagine, then the duration, equipment, and working methods, so the setting, as well as the crew and crew selection, varies from mission to mission. And I would like to cite the head of the Lunaris research station, where I've spent my analog space mission in, Leszek Orzechowski. To quote him, he said that an analog mission is a research method focused on investigating one or several aspects of crewed space missions using earthly real-life situations as an analog to an off-world scenario. I think this summarizes it really, really well. And here, just to give you an impression about, there are really a couple of analog space habitats and stations all around the world. Some of them are led by a space agency, like NASA. There was just last year founded a new one from also the European Space Agency called Luna. There are some from the DLR, and as you can see, they're really simulating a couple of space surface aspects, the lunar, Martian polar caps, Mars. But on the other hand, there is also a huge number, even much more, civilian-led analog missions, so private analog space habitats, also all around the world, where they're focusing on simulating different aspects of space. Could be a planet, the moon, but also like um, interpersonal interactions. So the crew members are called analog astronauts. So they're part of the selected crew of a simulated space mission, and as you can imagine, and they're out of the huge variation of these analog space habitats, the selected analog astronauts have to possess or even learn different characteristics in order to be qualified to perform such missions. For example, if we think about analog space missions or habitats underwater, it's really essential and necessary that these selected analog astronauts do learn scuba diving in order to perform their mission. On the other hand, it's often like that every crew member gets a role assigned within this analog space mission in the habitat, and in order to be prepared for that role, the person has to be qualified for that, for sure. And uh, what's really important also to say is that a mission is about scientific research, but not about special astronaut training, as a training, for example, for a flight to the ISS or the moon. So yeah, you learn definitely a lot about the procedures of a real space mission. You get access and you develop protocols, how to prepare, for example, for an EVA, but you cannot state that you were then, after completing a mission or even a couple of missions, qualified to be an astronaut. What's also really important to say, however, that the time within an analog space mission and the analog space mission itself always is scientific research. So it's definitely not, let's say, fun where uh, like one decides, okay, I'm going to a mission tomorrow. So um, there is scientific research that even you have to perform, or is performed externally on you. So it's really, really a complex task of getting an analog astronaut, where you have a lot of responsibilities. This applies also to Lunaris Research Station, which is a simulated, or the synonym is an analog space habitat in Poland, in the city of Pilwa. And it enables simulated space missions on the moon or on the Mars. They have, as you can see also here on this image, on this photo, to the right, they have an EVA area, which is on the top right corner, which I will then introduce later on in more detail. And they have also some modules, and these are like containers in within constructions, but you don't have access to the outside world, so there are no windows. So you're really completely environmentally and socially isolated from the outside world, and with the opportunity of an excellent also EVA training in this EVA area on the top right corner, which is actually a bunker from the Second World War, filled, the surface is grounded with rocks from different sizes in order to really simulate Moon or Mars environment. And the modules itself, so the station is developed and constructed for 6 to 8 analog astronauts, also with physical limitations and disabilities, which is really, really unique and fulfills even the social development goal from the UN, under the Agenda 2030, the social SDG 10, which is reduced inequalities. So Lunaris is really trying to be inclusive in order to perform missions with especially abled people. And yeah, there is an EVA area where EVAs are performed. So there is the opportunity to simulate Moon or Mars mission. Uh, but within the module where the analog astronauts live, then within the 2 weeks, usually as the mission's duration, there is a focus on psychological factors, so human factors, of the crew's coexistence during the 2 week simulated mission. And as I have said, within Lunaris, the extravehicular activities, EVAs, are performed. And these are like these simulated space walks. And these take place in a hangar, which is connected to the modules of the inhabited part of the simulated space habitat. And it's around 300 square meters big, and it's completely also isolated from the real outside world, with respective to noise and light. And the area is filled with rocks with basalt and siliceous material that simulate, as good as possible, and in a really excellent way, the surface of Mars or the Moon. And the grain size varies, from very fine sand to larger rocks, also in order to be able to perform a couple of activities and the geological tasks. Um, and the hangar area, or EVAs in general, as you can imagine, also as in real astronautical scenarios, are perfect for the development of procedures for analog research related to emergency situations, security, communications, planetary research, and suit and instrument testing. There are, for example, also scenarios where you have to really the emergency tasks, evacuation, and also getting shielded into a tent, which is there. So really, really complex tasks that are or that the hangar area, the EVA area, could be used for. And during this simulated in EVAs or in general, the hangar is independent of the outside climate. And the simulated space area offers the possibility, therefore, to perform different scenarios and activities during a simulated spacewalk. It can be used for emergency scenarios or also longer excursions. So there's the opportunity even to stay overnight there in this tent, as I've said, um, where, as said, the analog astronaut team did not return to the inhabited home base for a night or even a longer extended period of time. And yeah, this last year in March, I fulfilled my dream. I became the first wheelchair using analog astronaut. Having spent with five other really amazing crewmates 2 weeks in Lunares, being on a simulated moon mission, which was really, really a unique experience. I'm really glad that, yeah, I was able to be there. And you have to imagine there is also a really strict daily schedule. So in the forenoon we had breakfast, and then either we had our work. So each of us had a role. Myself, I was the biolab officer, so there was a biomodule there, for example, and I performed in the forenoon some experiments there, which were also really, really interesting. For example, I had the opportunity to study seed germination in real Earth-like soil, but also in simulated moon soil. So I did the germination experiments of seeds and plants in meteorite powder, which was really, really great. And in the afternoon, usually we either had some also leisure time, but also this leisure time was used in order to fill in different questionnaires. As I've said, each mission is accompanied by a lot of researchers, where we had to fill out some questionnaires for them in order to be yeah, in order to complete the research. Or there was the time also, on the other hand, to perform every second day an extravehicular activity and EVA with different tasks, where two of us were analog astronauts. Every time, every EVA, there were like different pairs of analog astronauts who really went out to the EVA area in simulated space suits. So the dressing up, the donning, and was really, really complex. Also, it took us 1 hour to get into the spacesuits, helping each other, and then two other people also were the HAPCOMs, so called, and these HAPCOMs coordinated all the tasks that have had to be performed in the analog space mission. Um, yeah. So we communicated with the walkie-talkies to each other, and also having had support from Mission Control Center, which were the organizers from the habitat, but they were 3 or 4 hours away with the car, so really far away. Um, but they also have seen all the procedures and accompanied us through the EVAs. So maybe just to introduce the other crew members, top left, the guy. We were really also a diverse group from 3 continents. top left row, the guy was from Scotland. Then in the middle, in the top row, the guy was from Mexico, and then top right, the girl was from Poland. Next to me to the right is a girl from Colombia, and to the left is a guy from India. So, and each one of us had a different role. I was the biolab officer, and there was a medical officer, there was a commander, there was an executive officer, there was a communications officer, and also a mechanical engineer, which was really important, especially for the EVAs, to have everything technically ready. We had also a rover for the support for our EVAs and the mechanical engineer. Uh, Besides other like all other mates was also very important for the success of our mission. So here are a few impressions about the everyday life of our mission. Top left corner, here you see us just after the mission in the EVA area. So you see the rocks, and so it's really isolated also from the outside world. You see just the light from the flash. And on the top right corner, you see me in the biolab where with the plants where I did the germination experiments. And to the left, you see us in the kitchen module where we prepared some food for us, which was also limited. We got some food ratio in the beginning after 2 weeks, and we had one resupply. And it was, as you will see then in the later slides, um, there was mentioned that we had twice a day just freeze dried food, like on the real ISS, which just we just poured water in it and ate that. And as you can imagine, freeze dried food, it's like maybe not the most delicious food, but it was really okay to get some calories. And once a day, usually it was the breakfast, we had some kind of fresh food. We had some toasts with butter and ham and cheese and eggs. But everything was like calculated for the 2 weeks, so we had to be really careful with our resources. And to the right, you see one of my colleagues in the EVA area performing a geological task, I think. Um, and yeah, to the right, you see in this portion of freeze-dried food, and in the top, in the bottom, middle, and left, you see two photos where, through some walkie-talkies, I have coordinated as a habitat commander or habitat commander support the extra vehicular activities, also having in mind some values, like the simulated pressure of the spacesuits and all the values in order to accommodate for any real or simulated emergencies. And yeah, here I would like to just share with you two videos. To the left, you will see the moment where we got also an extensive training in order to be prepared for to survive there alone in the 2 weeks. And after the 2 days of extensive training, the Lunaris founders and people, representatives, went to their mission control center, and we had to lock us in. And this is a video where we are just locking us in, so we were locked from outside, also in case of some emergency, so that we could escape theoretically. And that's the video how we are locking us in, taking into account that we will not leave the station for the next 2 weeks.
Yeah, we are locking it. Yeah. All the modules sorry. Be locked. Yeah, may I? Oh, yes. So, Pablo, come.
You're also filming.
Josh, you being your vice commander, let you also be in the frame. Okay.
We're walking.
Great.
One more time.
15 times.
Nice.
Ah.
We're done.
You can hang the keys. Cool. Now biomodule.
So yeah, a really interesting feeling and experience now, having realized that we are there on our own for the 2 weeks, and yeah, maybe a funny story just afterwards. From this point onwards, we were in social and also environmental isolation. So social isolation meant that we weren't able to use social media to communicate. Also with the Mission Control Center, we were just through communication channel together. And after locking us in, we just wanted to perform some tasks. And in one of the modules, we have found a frog, a toad, which was like living there, and we haven't known what to do with that. And this was also interesting interpersonal, I would say, also experience. As I, for myself, as being the biolab officer, I would have seen me as the most maybe qualified person in order to make suggestions and decide what will happen with this animal, with this alien. But all the other people had also very interesting suggestions with that. But in the end, we have also texted the Mission Control Center, and in order to get rid of our garbage, we had a small kind of called window of life, it was called, where we every day put our bins in, our garbage in, and someone from outside took it out. And yeah, so we agreed with the Mission Control Center that that we will get this frog into a plastic box and get this into the window of life, so that the external mission support will get it from outside and free the frog, so that nothing bad will happen to this alien, to this animal. But it was really interesting. And the video now to the right was after the 14 days, after the 2 weeks of the mission. And maybe a two funny stories toward that happened and that I experienced towards the end of the mission. There was also a limit of water, so we had to limit our water consumption, and therefore we made plans who will shower on what day. And towards the end of the mission, um, we like someone was allowed to shower on day 13, the second last day of the mission. And we like discussed that, and some of my crew members told like, okay, I will shower on day 16 of a 14 days mission. So we really accommodated mentally and interpersonally so well, I would say, that we wouldn't have a problem in order to survive a couple days or even weeks longer. And on the very last day, we were already in contact with Mission Control Center, and they told us, okay, we are there you can now come out, and they brought us also some sweets and something good to drink, because also we weren't allowed to drink some coffee and the eating sweets or sugar with during the mission. And like they called us, yeah, we are there, you can open the door, which is this door on the right. And we were really like, we don't want to get out. We want to spend a bit longer together in order not to end the mission. So we let them wait for 2 hours in order to get out, which was also, I think, a good sign that the mission ended really successfully. But that was then the moment where we escaped from the simulation and yeah, enjoyed the real Earth after 2 weeks.
Wziął do środka. Krzyku go zostawił na dworze. Oh, that smells so good, actually.
You mean outside?
Yeah.
Yeah, okay.
Dzień dobry.
Hello.
Dzień dobry.
So, congratulations, guys.
I don't know if you've heard at the end, someone of us told it smells so good outside. So I think you learned to appreciate the really, really small things after or during this 2 weeks mission. And it was really interesting of being then outside. And I don't know if you have also seen that to get outside there was a little ramp. So this is the specialty of the Lunaris analog space habitat, that there are ramps everywhere needed where there are steps, so that even me as an active wheelchair user can get along. Oops. Yeah. So we how much time do we have, Kristine?
You can go. Yeah, the whole time is yours, so don't worry.
But how many minutes do we have?
Right now we're at 40 minutes.
40.
Yeah,
Okay, perfect. Perfect. So maybe just I would like to quickly introduce some other initiatives that are also promoting inclusion and diversity in the space sector. One of them is another cool analog space habitat, which is called Hydronaut. Hydronaut project, where the chief scientific officer comes from Slovakia. It's Dr. Miroslav Rozložník. Is a research and training station designed for short-term, but also longer-term stays of really small groups of people, 3 to 4 people, underwater and on land. This is really a cool thing, that it's not only the world's smallest analog space habitat, but it can be also used underwater. Also constructed with scuba diving experts. So you can really perform with this analog space habitat a mission theoretically underwater if the crew members are skilled. And there, as you can imagine, there are diverse applications for research. So there's the effect of isolation and extreme environments on the human psyche, or testing functioning technology under extreme conditions. Not only that it's really narrow, I think the whole habitat has 6 square meters, like that. It's really, really tiny. So it enables the simulation of analog space mission in an isolated, closed, and extreme environment underwater. But currently, it's on the surface, on land, in Prague, in the Czech Republic. And you can test those communication delays and shifts of the circadian rhythms. Second, not maybe analog space habitat in the narrow sense, but also initiative that also promotes inclusion in the space sector is from the US. It's called Astro Access. To my knowledge, the managing director is Anna Felker, and its project to promote the inclusion of people with physical disabilities in manned space research. And they're performing parabolic flights, so zero-G missions, and they've conducted 5 with people with various physical disabilities. And these Astro Access ambassadors experience this zero-G and test accessibility tools and research for the specially able people, and how the physical environment on board a spacecraft can be designed so that all astronauts on Earth, regardless of their disability, can work and live in space. Next project is or initiative is CHASM, the Community of Human Analog Space Mission, which was founded by Eleanor Pauly, a good friend of mine. And CHASM summarizes the knowledge about simulated space missions and the resulting research opportunities for the scientific community and the general public. And maybe to get to the next bullet point, CHASM, for that purpose, hosts conferences and workshops. Uses also social media to connect analog space mission organizers, but also participants from the general public, also analog astronauts and the wider space community, in order to get the most of this information. And available opportunities in this field are shared via social media. And one of the groups, subgroups of CHASM, is called PyroCHASM, which I'm the lead of. We are providing a platform for information exchange for organizations wishing to discuss future missions and information gathering strategies, and research excellence on the topic of simulated space missions in the context of specially able people. And our aim is to prepare the path and conditions for the para-astronauts, first on Earth, but then also in space. And we are collaborating with a couple of institutions. So CHASM is really, I would say, a great initiative to know more and get involved in analog space research. And the last project I would like to introduce is the SGC, the Space Generation Advisory Council, which is a global non-governmental nonprofit organization for students and young professionals aged 18 to 35 within the United Nations. And to connect, its aim is to connect this with the United Nations itself, space agencies, industry, and academia. And their aim, their mission is to support the young generation in progress of humanity through the peaceful use of space. And there are several subgroups to reach this mission, this aim. And I'm a member of the working group on promoting diversity and inclusion in the space sector. And the group deals also with the topic of diversity and inclusion of para-astronauts and astronauts in general. So yeah, that would be the end of my presentation, and I would now encourage everyone who would have any questions to ask anything you would like to know. Thank you very much.
Yes, thank you, Thomas. So, yeah, I'm very proud of this project and very proud of Lunaris for doing inclusive analog space mission. So, yeah, if anyone in the audience, if anyone in the participants who would like to ask or who has any questions, you can raise your hand or you can open your mic. You can chat your questions in the box or in the chat box. So yeah, feel free to ask questions to Thomas. Dear Jan.
Hello. So it's fascinating how, like for you, for your experience, people on wheelchair have the capacity to be able to join like analog space missions. But have you ever encountered, or do you have an idea how it would be for blind and deaf people? Do you think that would work, or do you know anyone who has experience with that?
Yeah, thank you for that question, and it's definitely a relevant point. Also, with Paracasm, we are trying not only to focus, definitely not only to focus on wheelchair users, but to promote this analog space world for everyone having different disabilities. And in fact, Lunares did also a mission already with a blind person. It was actually their first mission, analog space mission, uh, which they conducted in 2017 back then. And it was a great success. So at least Lunaris is adapted for blind people, I would say. With deaf people, to my mind, there weren't any missions yet. But what I can tell you that within this emergency scenarios, there is a training with sign language, and the sign language. It's funny because it's kind of a mix of their own sign language and also sign language from the scuba diving world and also from the real sign language, because okay, one cannot say the real sign language because every country has its own sign language for deaf people. But yeah, it's kind of a mix. And in one of the last CASM conferences, we have trained to perform sign language, British sign language, within spacesuits. And it was quite a fun experiment. So I am looking forward already to a mission with the first hearing impaired person, whenever it will be.
Thank you both.
Thank you.
That. So Jody, you're raising your hand.
Yeah, hi. Thanks. This is a really good talk, Thomas. So I'm with Stanford Medicine as well as Astro Access. So just a little background: we've had 7 to 8 actually zero G flights, as well as a lot of our members, including myself, have done analog missions, including those with low vision, deaf, blind, paralysis, amputees with prosthetics, and actually neurodiverse as well. Sherry Jensen Wills actually did an analog with, she's blind, so that was extremely successful. We've had Mary Cooper and Michi. They're both. One has a prosthetic, one uses wheelchairs, also have done kind of that analog, being in for 2 weeks, as well as Eric did the water. He's deaf and was underneath the water for quite a while, so as well as others. So my question, because I'm an occupational therapist and does a lot of the modifications, right? I was really wanting to know how your daily living skills were. And I'm going to be really, like getting, donning and doffing your flight suit, being able to use the bathroom if, depending on if catheterizations, like how was your daily routine of accessibility, and were you totally independent?
Yeah, that's a really good and important question. Thank you for that. And so I would say the most tasks, most of the tasks of the daily routine, I was really completely independent, as the bathroom module was adapted for also wheelchair user. However, the hygiene routine is different for everyone, but it could have been also adapted from candidate to candidate. I know that Michi Benthaus, who was the Astrax ambassador in a wheelchair, was the next wheelchair user after me, right after me, who completed also a mission in Lunares. Even us two wheelchair users are not comparable within our needs. So some aspects were adapted also for her that I, for example, didn't need, or for me that she didn't need. But what when it gets to the, let's say, the kitchen module, The kitchen module was really, really difficult for me to reach some aspects and to get along there as a wheelchair user, as I need some space in order to get beneath the shelves and the kitchen module with my wheelchair, and also get some space for movement. This was really difficult. But other than that, other than the kitchen, also within the biolab, most of the things I could have done, or I did on my own without any aid. Sure, if there were things on the shelves that I couldn't reach because of my height, I asked for help, but the general things were quite good, developed already and adapted.
Great, thank you very much.
Thank you also, Jody, and good morning to you. It's about 6 a.m. over there. So we have a question here in the chat from Vindra. I'll just read. Are there any plans or possibility to include persons with dynamic and limiting physical cognitive disability, such as long COVID, dysautonomia, etc.? Interesting in hearing your thoughts.
Very interesting question, and I have to say, unfortunately, I don't know what the plans for people with this dynamic or limiting physical and cognitive disabilities are. What's an interesting question is with, let's say, cognitive disabilities, cognitive impairments. It's a highly debated topic. If people having this should and will be part of these missions, as there are also often cognitive tests in order to be qualified as a crew member. Because you have to imagine there are like missions that are really extreme, maybe not from the environment, but also from the time being isolated from the environment. It's also not easy for, let's say, a mentally healthy person. Even us within our mission, we used some tricks. We were allowed to watch videos of nature on YouTube, for example, in order to mimic the outside world, kind of. But there are mission. I had the honor to get one of the analog astronauts from the Mars 500 mission. So this means they were locked in 500 days, which is more than a year, which is really, really tough, I would say, for the cognitive state of a person. So it's an interesting question, which I think is not solved yet.
Yeah, if I may add to that. So, Thomas is correct. We also do a lot of cognitive tests, also in my mission, before and after my mission. And I think we can, for me personally, I think we can use that to study our cognitive functions in space, actually, because I read a paper just recently that our cognitive our cognitive functions are slower when we're in space. So maybe, like for example, long COVID, maybe we can use them like to simulate, do an analog, probably. So that's probably an interesting study. So yeah.
Yeah, thank you.
Do you have any more questions in the audience? I have a question. So
Yes.
Because we usually think that disability is limiting our, our functions when we go to space or when we do analog missions, space missions. But do you think, do you have a certain advantage over like, with people without physical disabilities? Yeah.
I would definitely say so. Like I'm not an expert for every disability. I can just talk about um, my disability, or let's say the symptoms of my disability in the broadest context as a wheelchair user, or someone having a spinal cord injury, or having the effect that I cannot use my legs. As there is even weightlessness, zero G in the space, the astronauts up there, let's say on the ISS, do not need to use their legs in order to move forward. And as me in a wheelchair is really used to use my hands, not only for getting forward in a wheelchair, but also for, let's say, manage my whole life, just, let's say, with my arms. I would say I would have the advantage of having these skills already now without having to learn them. So I could imagine that people who use their hands more extensively, or maybe also the other way around, who do not use their legs, or have some leg impairments. Even the newly selected ESA astronaut John McFall, who has prosthetic one leg. I wouldn't say that this does matter in a negative sense. I would say this could even be an advantage.
So we have another question from Zilias. Is there
Yeah.
anything you would have liked to train for or prepared beforehand, thinking of future para astronauts, how their training should be adapted accordingly?
This is a good question, and I think this um, is dependent on, and this differs from mission to mission. In fact, the aim of the Paracasm group, which I've mentioned within CASM, is to develop some universal criteria in for the selection process, or for the needs of para-astronauts within analog space missions. But this is really, really complex task, because every disability, even as I said, this friend of mine and the Astro Access candidate in a wheelchair, Mickey Benthouse, and me, we are both wheelchair users, but we do require different things. So I think, yes, in the end, it would be helpful and important to have such universal guidelines. But if we will get this in the near future, or even if we will get them at all, it would be very, very complex and difficult to develop them, because of the huge variance of the disabilities, I would say. But yeah, maybe just a little add-on. As yeah, there are for sure differences from individual to individual, from disability to disability. I would say the main challenges remain the same for one category of disability. So maybe sharing experiences within, let's say, for example, wheelchair users, or hearing impaired people, or blind people, having experienced one of the and the same analog habitat would help. Already helps.
All right. Thank you so much. It's past two. Uh, two. Yeah. So it's we're over an hour now. So again, thank you very much for attending our very first episode for our IAU Inclusive Astronomy webinar for this year, 2025. And thank you very, very much, Thomas, for sharing your experience and recommendations for inclusive space exploration. So, hope everyone will have a or is having a good Sunday. Or yeah. So, thank you very much, and hope to see you again in our next webinar. Thank
Thank
you.
you very much, Kristine, for the invitation. I'm very glad. Thank you.
Thank you.